ಸರ್ ಸರ್ ರೀಸೆಂಟ್ ಆಗಿರೋದು ಬಂತ ಸರ್ಟಿಫಿಕೇಟ್ ನಿಮಗೆ? ಮತ್ತೆ ನಂಗೆ ಬರ್ತಾನೆ ಇಲ್ಲ ಅದು ಸರ್ಟಿಫಿಕೇಟ್. ಬರ್ತಿಲ್ಲ ನೋಡೋಣ ತಗೊಳ್ಳಿ. ಮಕ್ಕಳಿಗೆ ನಾನು ಇದಾಕಿನಲ್ಲ ಸ್ಲೋ ಆಗಿದೆ. ಹೌದಾ? ನಾನು ಮಾಡಿದ್ದೆ ಒಂದು 10 ನಿಮಿಷ ಆಯ್ತು. ನೀವು ಮಾಡಿದ್ದು ನಾನು ಮಾಡಿದ್ದೆ, ಬಟ್ ನಂದೇನು ಬರಲಿಲ್ಲ. ಅದಕ್ಕೆ ಕೇಳ್ತೀನಿ ನಿಮಗೆ. ಹೌದಾ? ಇನ್ನೊಂದ್ಸಲ ನೋಡ್ತಾರೆ ಸರ್ ಇನ್ನೊಂದು ಮೊಬೈಲಿಂದ. ಓಕೆ ಓಕೆ ಓಕೆ. Hello, good morning, Vaibhav sir.
Good morning, sir. Very good morning.
Had your breakfast, sir?
Yes, sir. Yes, sir. Just a few minutes before I had. What about you, sir?
Yeah, I had, sir. We
Okay,
can
great.
start at 11 o'clock, sir.
Yes, of course, sir. Of course. I am ready with all the equipments.
Okay, sir. Okay, thank you.
Yeah, yeah.
Yes, Anisha ma'am.
Yes, sir.
Good morning,
Good
ma'am.
morning, sir.
Can
Good
we
morning, sir.
start the session, ma'am?
Yes, sir.
Okay.
Good morning, Vibers.
Good morning, madam.
Yes, sir. Can we start, sir?
Sure, no problem. So, is there anything
Sir,
formality?
no, sir. Sir, yesterday some students are facing still some problems in installing that software, sir. Can you
Yeah, no
brief it
worries.
once?
Yeah, sure. No worries, no worries. I'm going to walk through with that procedure as well.
Yes.
Great,
With
great,
that, you
great.
can start. Yes.
Great. Amazing, amazing. Thank you.
Thank you,
Good
sir.
morning, everyone. Hello, hi. Good morning, good morning, good morning. Welcome back to PCB Workshop for Absolute Beginners for 2022. And I'm Bible Sugandhi. Yesterday, we started with a 2-day workshop on PCB designing. I hope you guys are connected with us yesterday and you attended yesterday's session. I think there is a YouTube video for that as well. It's a live streaming, so you can watch it again and again. That's a great thing that Ravi sir and Anusha madam has organized, which is amazing for students who are missing some part of the entire workshop. So, having said that, a very good morning to everyone. I'll quickly go through certain points which we left yesterday, and I'll start with the main content today. Um, one small information to you guys. So yesterday and day before yesterday in Dharwad district, it is 10.8 degrees Celsius temperature. It is too cold in our office because our office is having good ventilation and all those things. So if I'm sounding a little bit low today, please apologize for that, because human nature, I cannot speak too much because of little bit of cold and all those things. Okay, so I hope, having said that, I just wanted to quick have an interaction with you guys. Anyone who are attending today's workshop without attending yesterday? Anybody? Just say yes for that or no, whatever it is. I mean, if you are attending just today without attending yesterday's session, just say yes for that. If the number is big, then I'll be repeating some points just in a short period of time. So that's why I'm asking. Try to respond to me in the chat window of Google Meet, as well as in YouTube also. I'm able to see YouTube chats. So you can text me both the way. As always, yesterday we discussed, right? Go ahead, guys, go ahead. So if you are having, anybody of you are attending session today without attending yesterday's session, do let me know quickly. If there is no majority of people who are attending today, then I think quite easy. So I'll just go with the installation of ECEDA directly rather than explaining some points in a kind of recap manner. I hope none of you, because it is already a Sunday morning, so nobody get that much of motivation to join us on this particular learning program, I believe. Is it so? I hope every one of you are from Davangere district or something. Anybody is from other than Karnataka or any other place than Davangere and other cities? Try to respond to me, guys, because this is already a Sunday morning, and if you do not respond to my question, it becomes a very boring one, not only to you, even to me. Venkatesh says, I am Davangere. That's amazing, sir. Wonderful. What about you, Kiran? Kiran said no. That means you attended yesterday's session, I believe. What about others? Only 2 3 people are responding. No motivation, no motivation for Sunday morning. You should not be like this. From Davangere. That's great, actually. I mean, I can see 2 3 people are from Davangere. What about others? Benne Nagari Davangere only, sir. That's amazing. That's amazing, Nagraj. Wonderful. Davangere, that's a great thing. I don't think so. Anybody is from other than Davangere, because your college is located at Davangere, but probably there are some students who are from Hubli who went back to Davangere for studying in college and all. That is a possibility. So that's why I'm asking this question. Vijaypur, that's amazing. And somebody said Harrier. Sahana from Harrier, that's a great thing. Ballari, that's amazing. Harrier. Ballari. I think group of students are there from Ballari, Harrier, and anybody from Hubli actually. Anybody from Hubli? I mean, staying in Hubli, born and brought up in Hubli, raised in Hubli, but studying in Davangere College. From Hosur, studying in Davangere. That's amazing. Raichur. That's really amazing. Very good morning. In YouTube also, so many people are saying no for that. I mean, that means they have attended yesterday's session, I believe. So please go through the YouTube chats also. Yes, I'm going through YouTube chats as well. I have two windows, one window as a YouTube chat and the window as my Google Meet. So I'm looking at it. Oh, finally, somebody from Chitradurga. That's amazing. And then Bagalkot. That's amazing, Kiran. I'm also studied in Bagalkot for say 4 to 5 years, 10th and diploma 3 years, 4 years, I guess. Pradeep from Dharwad. Hi, Dharwad. Hi, Pradeep, actually. In your district, I mean, if you are staying in Dharwad, then here the temperature is 10.8 degrees Celsius yesterday. Maybe yesterday or day before yesterday altogether, I guess. So I hope you could feel that. What is the difference between temperature? We always used to stay in, sunny days and all. I mean, we are supposed to say it's too hot in Hubli Dharwad, but this time it's going down, down, down. I don't know till what level it goes down. All right, all right. That's amazing. Good to interact with you guys. Thank you for responding. Let's start with the session. First of all, we had a wonderful session yesterday. I personally believe it was a wonderful session, and I also believe that you also enjoyed the same way. Having said that, those people who has some problem with respect to installing EasyEDA, I'm going to help you to that particular process, and then I'm going to help you to create your schematic and layout today. Today is going to be the most important thing. Why? Because we are spending a lot of time on understanding the real work. The entire PCB designing workshop is focused on today's session, the schematic design and the PCB layout. Okay. So first of all, it's a basics of PCB designing workshop for 2022 students from Key Innovation Private Limited, and we also have a company UTD and a linked frequency, which is a YouTube channel. And this particular workshop is organized by Jain Institute of Technology, Davangere. So as we already discussed yesterday, our agenda is already half completed. So introduction to EasyEDA tool and its environment is completed yesterday, wherein understanding and designing a schematic diagram was planned yesterday, but unfortunately we couldn't do it because of running out of time. So today we are going to do it with as quick as possible. Thereafter, we are going to talk about the footprint and symbol, and then we are going to design a PCB layout, and there is some assignments for you guys to practice after this workshop. So as already said, yesterday we used mind map to discuss several parameters, several terminologies which are essential for PCB designers. Can somebody tell me a couple of parameters that you remember? Maybe you can tell me one or two. No necessarily to say me the definition of that. If you can do that, that's amazing. You can turn on your mic in Google Meet and you can talk to me directly saying what exactly the definition you remember about those terminologies. If not, at least in the chat window, please type what you have understood yesterday. What are the terminologies you remember? This is going to serve as a evaluation metric for me to understand how effective my teaching is going to you. So in YouTube also, I'm looking at you guys. So let me know what you remember yesterday. What are the terminologies we discussed? Just to verify, am I audible to you guys? My audio is clear to you guys, and also video and screen sharing. All three are clear to you guys? Yes or no? Great. Thank you. Thank you, Dinesh. Thank you, Sahana too. PCB layers, sites of PCB, terminals, and connectors. That's amazing, Nagraj. You remember most of the things. I think four important terminologies you remember. What about others? What about others? PCB layers, PCB vias, clearance, and isolation. That's amazing. That's amazing. What about others? I'm also looking into a YouTube channel. So let me know, guys. What do you think about it? Sai Suchet is saying something. PCB layers, PCB bias, sides of PCB, track width, clearance, isolation, footprint. Wonderful, wonderful. That's amazing. Most of the definitions are with you, Sai Suchet. If you had made a notes, I think quite easy for you to tell all the 10 of them. But if you have not done that, then probably you remember most of them. Very wonderful. Sides of PCB, SMD and THT, that's amazing. Footprint and solder mask, that's amazing. SMD and THT, footprint symbol system, schematic and layout. What is this, Sachin? F, SMD and THT. What is this F? I think you had a typo, I guess. Track width, clearance and isolation. PCB layers, vias, sides of PCBs. It's not just a sides of PCB, because sides doesn't have proper meaning. Track width, that is good thing. C, silk screen. What is that? C indicates Navya. So and shoulder mask, track width, that is amazing. Track width also, that's amazing. That's amazing. There are some people who are texting me in the YouTube as well. PCB layer, PCB bias, sides of PCB, footprint and symbol. That's amazing, Pooja. Actually, most of you, most of the definitions are with you, and I hope you have made notes for that yesterday's session. That's amazing. SMD, THT, schematic layout. That's amazing. That's amazing. Enough. Thank you. Thank you so much for that response. And I personally believe you guys are. Dinesh is also talking about need of PCB, how we can make PCBs, tools to use for designing PCB. That's amazing. Great. All right. So most of you are able to remember the things which I conveyed you yesterday. That means I'm good at speaking. Just taking a joke on me, but yeah, I hope you are enjoying and also the message is conveyed to you. Having said that, let me quickly jump into the next part of the video. Next part of the session. So creating an account with a easy EDA tool is quite easy one, but I don't know why you people are feeling a little bit uncomfortable with that. No worries, I'm going to help you with that process. So quickly jump into screening my share. So where is a window? Okay, I need to check with the window. Here it is. Okay, just a minute. A tab is EDA. Sure, that's amazing. Can you guys able to see my screen, guys? My Easy EDA website screen is visible to you, right? Yeah, wonderful. Thank you. Yes, amazing. Thank you. Great. So now, first thing, whether you want to do it online or offline, that is the most important thing. Offline doesn't mean you need not to use the internet. Of course, you need to internet in either way. First thing is you can use this tool as a website editor, web page editor kind of a thing, or you can even download it and install it in your computer. So if you want to download it and install it in your computer, you can click on this download section, and you can always download the required version and you can install it very easily. There is no procedure in that, but most of you are not able to do it. That's why I'll not struggle or I'll not customize this entire tutorial to make you people install with a different operating system that you guys are having. Instead of that, I will recommend you to create your account in this online editor itself. You can see here on the top side, I hope my cursor is visible to you guys. Is there any notification? No, nothing. Okay, so I think my cursor is visible to you on my screen. So you can see here there is option called login and there is option called register. You can click on the register option, and no need to download anything, no need to install anything. Just go to that particular page, home page, and then click on the register option. Then this kind of a page will appear to you. Either you can create your own username and a password, which is good to do because no need to share your any personal data with the Easy EDA team. But still, if you are not able to do that and if you are not able to maintain that login credentials and all, you can click on the sign in with Google. So once you do that, sign in with the Google, it will create an account for you. I think now it is asking which account you wanted to go with. So in any one of your account, you can click on that and you can log into it, and then probably you can go ahead and log into it. But right now I need not to create an account, so I'll click on the login here. Are you guys clear with this? Are you guys able to do this one at least? Try to do it in parallel. Actually, whenever I'm speaking, you keep one window for Google Meet and another window for your activity. If you have already downloaded it and installed it in your computer and looking for registering, that is also the same procedure. There also in the window, I think I'll share that window also. I'll do one thing. I'll share my entire screen. That helps you to entire screen. Here it is. Good to go. Are you guys able to see my screen? Now it is visible. That's amazing. So the same way how you are having a register and login option in this particular website, it's not a downloaded version, it is a website. The link is very simple, like download section or maybe home page also, easyeda.com. You can see there also login and register. You can do that as well. Or if you want to go with your software, once you download the software, once you install the software, this kind of a folders will not appear to you because you have not done any project, any folder before. But you can see your login and register option on this particular section. I hope you guys are clear now. If you have downloaded and installed it, then click on this register option, register it, and then click on the login option. You could able to log in very easily in the client version. But if you are not able to do that, then no worries. You can always go to this particular online editor and click on the login option. After creating the account, you click on the login option. In my case, I have used my Google sign in for easy EDA account creation and all. So I'll click on the Google sign in. So I use my personal account for this. So once I click on that, you can easily see that it is getting logged in very easily. Now you can see that my profile is visible to everyone. Are you guys able to see this? Are you guys able to do this till here? Till here? And the moment when it is logged in, then nothing to worry about it. It is quite easy to go ahead here and after. You just need to click on this Easy EDA Designer. The moment when you click on Easy EDA Designer, window will appear to you. This window, you can click on the skip for that. You can see here. This is absolutely my online editor. This one, whatever you are seeing right now, this is a website version of my Easy EDA tool. It is absolutely similar as my local client version. But don't assume that if you have downloaded the local client version, you do not need internet. Nothing like that. You need internet in both the way. Whichever you feel comfortable, you can use it. If you want to use a client version, keep it local and want to use it as a local software, then you can do that. Otherwise, you can always go to website and log in like this, and you can see the same interface as your client version. Are you guys clear with this? I hope you guys are able to see this much at least. Done with everyone? Done with this particular process? Okay, there are so many comments in chat for YouTube. Pratibha is segregating so many definitions which we discussed yesterday: PCB layers, PCB wires, sides of PCB, terminals, connectors, track width, clearance, and isolation footprint. You forgot about a symbol, I believe. So that's a great thing. Actually, you remember most of them, Pratibha. That's amazing. Great. What about installation process? Are you guys completed with this installation process or logging in process? Say logged in the chat window. Say logged in chat window. I'll proceed further after listening or after seeing the comment like logged in. Quick. Okay, I can see most of you are typing logged in chat window of Google Meet. Of course, I'm going to watch in YouTube as well. Type logged in in YouTube actually. In Google Meet, most of you are saying logged in. That's amazing. Great thing. I hope you guys are clear now actually where to install and how to install and how to use this particular software. I'll wait for another say 2 minutes because it is already 11:18. So I'll wait for 11:20 and we'll start with designing your first schematic. I'll share the screen and you keep it ready. No. This should be done something like this only. Otherwise, it doesn't look good. Fast, guys. So please complete the logging in process as soon as possible because we have a lot of things to do for today. So make sure that you're done with that. Wonderful. In YouTube also, most of you are saying logged in. That's amazing. That's really amazing. Fast, guys, fast. It's really great to see that 101 people are showing up in Google Meet, and I think 44 people are watching in YouTube. Thank you so much everyone for your motivation on Sunday morning. That's amazing. It takes a lot of motivation to wake up on the Sunday morning, isn't it? A- At least in the city, like having 10.8 degrees Celsius temperature. That's just very cold, actually. Okay, all right. So it's 11:20. I believe most of you are logged in with this. I hope there is no problem for you people to, logging in with the software. If you still have a doubt, then no worries. You just go and ask your guru, who is a Google. Google is a new guru for us, right? So you just go and type there how to install EasyED in a Windows PC, whichever version you have, 64-bit or 32-bit, or maybe in the Mac version. If it is not possible, then just don't worry. Go and log in the website version, which is a web editor. Just start designing your PCB over there. Not necessary that you need to have a local client version only. Okay, it's helpful some cases, but for you, I think as a beginner, it doesn't matter anyway. Okay. So having said that, let me quickly jump into the today's concept, which is all about designing a schematic. So what is schematic? Yesterday we already discussed what is the difference between circuit diagram and schematic. Can somebody tell me what is the core difference between circuit diagram and schematic? I think you can turn on your mic in Google Meet and talk to me directly. I'm sorry for the people who are attending on YouTube. I can still see your comment section. So if you really want to talk to me, then please comment me over there. But for Google Meet people, I think you can talk to me directly. Can somebody tell me what is the core difference between schematic and circuit diagram? Come on, guys, be interactive. It's Sunday, guys. I already told you, right? If you are not interacting, then it becomes very boring for everyone, not only to me, even for everyone. Try to say something, even though it is wrong, I don't mind. And there is no exam for this, fortunately. Go ahead, go ahead, go ahead. So, what is the core difference between circuit diagram and the schematic?
Sir, in the circuits we are using for a symbols to draw, sir. In the schematic we have used the pins of that uh, which we use components.
Absolutely right. I mean, you are almost there, but just a little bit adjustment. But yes, absolutely correct. In circuit diagram, it is mostly like hand drawn, mostly like, or maybe sometime it is not IEEE standard based. Say, for example, if it is a resistor, we usually draw a resistor like this, zigzag, right? But in the circuit diagram, when we are drawing on the paper and all, we used to use whatever the symbol that we feel correct, and it is not standardized because we are human being, and our handwriting not going to be a standard all the time, like how we do the typing and all. So because of that, circuit diagram is mostly like a circuit on the paper, non-digital format. But when you do a schematic diagram of the same circuit, it becomes a digital form. We do it with the industrial, international, and IEEE standards, which are defined for the entire globe, and also it is done by software. So there is a consistency in every resistor that you drag and drop from the library, and also it is easy to understand by everyone who throughout the entire globe. So that is the core difference between circuit diagram and schematic diagram. So circuit diagram is graphical diagram. In schematic, it's a graphical symbol. No, Pushpak. Actually, I mean, you are a little bit confusing us with the definition. Graphical diagram is not a correct term to use here. Instead of that, you can say circuit diagram is a handwritten circuit on the paper, probably, and schematic is all about a graphical representation on the computer. So that's a core difference between schematic and circuit diagram. Thank you. Okay, there is one more comment. A circuit diagram uses simple images of a components. A schematic diagram shows the components and a standardized symbols representation. Absolutely true, Rukia. I'm sorry if I'm pronouncing your name wrong. So, Rukia Khazi. So, you are right, actually. I mean, your definition is up to the mark. That's amazing. What about people on YouTube? Circuit diagram is base for the schematic diagram. That's true, Sushma. Actually, whatever you are saying, Sushma KS, circuit diagram is base for schematic diagram. Absolutely true. And schematic diagram is at industrial level. Absolutely true. Again, Sushma is saying the same definition. That is true, actually. That's how it is all about. Great. All right. All right. So now you can see that on the screen, you are able to see some circuit in front of you. This is a 5-volt DC power supply using 7805 regulator IC, which is a linear regulator IC. And the circuit diagram, um, this particular circuit diagram is a quite common for everyone. I personally believe, even you are not an electronic engineer, probably you are from mechanical background or maybe from computer science background, probably I believe you have studied this somewhere in your first year of engineering as a basics of electronics, before dividing yourself into the core branches. Or if you are from a diploma background, then probably in the diploma in the first semester there is something called basics of electrical and electronic circuit for everyone. So there, I believe you have studied something related to power supply. If you have not studied, sorry for that. Just look into the circuit diagram. Sorry. So first of all, we have a transformer, which is inductor core transformer, which converts AC voltage, high end AC voltage into a low end AC voltage with the same frequency and the current rating. So that's how exactly the transformer is all about. But we are not going to consider the transformer in the PCB designing, because there is no such transformer we can place on the PCB directly. Okay. So we are not going to use a transformer. Instead of that, we are going to use a connectors and terminals for connecting those transformer to terminal. Of output terminals are there, na? 9-volt AC, 1 ampere, whatever the outputs are coming, that particular tab we are connecting to the terminals, which we discussed yesterday. I think we have a PCB here. I'll take that PCBs later. So those kind of a green color terminals we are using in the schematic diagram, because we need to make it a PCB, not just a breadboard connection and all. Thereafter, we have a rectifier circuit. We can use a rectifier IC directly, which is like a round color or a square, round shape or a square shape IC, which is available in the market directly. Or you can always use a 4 individual diode with a 1N4007 part number to build a bridge rectifier. So thereafter, we have a capacitor of a 470 microfarad of a 15-volt, or maybe double than the input voltage. Whatever the voltage coming here, it is somewhere around 9 volt. So double than 9 volt is 18 volt. We will not get 18 volt capacitor generally, which is not popular one. So that's why we go for a 20 volt capacitor, or maybe 25 volt capacitor, or maybe in safer side we go for a 35 volt capacitor. So we need to make sure that 470 microfarad capacitor has to be added as a smoothing circuit, which will convert pulsating DC into a sharpened DC, which is a better version of a DC voltage. Still, it is having a certain irregulation. That's why we need to use a regulation circuit here, which is a regulator, linear voltage regulator. 7805 is a linear voltage regulator. It has a coupling and decoupling capacitor for removing a high frequency impulses, which is a little bit deeper technology or deeper information with respect to electronic engineering. If you are not familiar with that, no worries, just copy the same circuit diagram. How to get this circuit diagram? Again, it depends on the purpose of your circuit diagram, for what reason you are designing the circuit diagram. If you are designing the automation circuit, say for example, there is one light in our office. Whenever I come and sit here, there is one light here and there is one more light source here, or maybe the camera here. Whenever I come and sit here, these 3 equipments should turn on by default or by automatically. In that case, the circuit diagram becomes completely different. There is no need of power supply only. There are some adapters which we use, and there is a connector which helps to get that adapter output voltage into the PCB. So there is a different circuit diagram for that particular application. But right now, we are building a single voltage power supply which converts a 230 volt DC into a not DC, 230 volt AC into a 5 volt DC output. So this particular circuit diagram we are designing in this particular workshop. Okay. Having said that, this is how the circuit diagram looks like. We do not have any specific details here. You can see that there is no numbering for other components. Like this component has 1, 2, 3 numbering, wherein this particular diode is not having a numbering, but it is symbolically representation. But have you ever seen in any software, like in a PCB designing software, at least right now in Easy EDA, we are going to see that there is no black color symbol for the diode. But in the circuit diagram, we can use a black color symbol because it is a circuit diagram. It is just for your understanding, not necessary that it should be understood by everybody in the entire globe. Not necessarily, but still it is symbolic representation. So most of the people will understand just like you. So it is quite okay. This is all about the circuit diagram, which we are going to do for today. I hope you guys are clear with the circuit diagram. Do you have any doubts with respect to circuit diagram? Okay, there is a big comment in YouTube as well. pictorial and simple image of a components, and in schematic shows the component and interconnection of a circuit using a standardized symbolic representation. Pratibha, your answer is little bit here and there because it's not a pictorial and a simple image of a components. It is interconnection of components as well when it comes to circuit diagram. Not necessary that in the schematic only we need to do the connection. Even in the circuit diagram, like now whatever you are seeing in front of your screen, it's a circuit diagram, but it also has a circuit interconnection. Which pin of the one component is connected to another pin? All that thing is already defined in the circuit diagram. So a little bit modification is required for your definition, but I hope you are using a technical words. That's really amazing. All right, so do you guys have any doubts with respect to circuit diagram? And by the way, how to find a circuit diagram? That is a good question to answer as a FAQ, means frequently asked question in my all the tutorials, or maybe in the workshop, whichever I have conducted for guest lecture on other colleges. So see, when we are searching for a circuit, we must know that what exactly the application we want. If it is related to converting 230 volt DC into 230 volt AC, sorry for that, 230 volt AC into 5 volt DC, then this kind of a circuit diagrams are quite easily available in the internet. You just type as 5 volt DC power supply using 705, you will get it. But if it is related to some customization, as I told, automation of these lights when I sit here, then it is absolutely a customized mini project. On that case, you have to identify individual circuit, make sure that they are working together on the breadboard. First of all, it's so-called prototyping or experimenting. Once it is working, once the circuit is completely working, then you can come back to the circuit diagram, draw the final circuit diagram on the paper. Then you can come back to schematic design to make it a standardized product. So that's how exactly the circuit diagrams are identified usually. So do you guys having any doubts with respect to circuit diagram? Wonderful. No from one person. I think none of you, because already I explained too much about it. Okay. All right. That's amazing. So let me check what is left for us in the next slide. Okay, there are something called symbol and footprint, which I will come in the later part. So now let me stop sharing this and let me start sharing my another window, which is easy EDA window. Okay, here it is. Okay, great. Wonderful. I believe you guys are able to see my screen right now. Yeah, it is visible, I believe. Yeah, that's a good thing. Thank you, Dinesh. Okay, so right now, as I already said, you necessarily need not to use a client version of the software. Even in the website editor, you can literally see the same user interface. So need not to worry about it. Just see wherever it is possible for you, you can use it. Okay. So yesterday we created a project, right? I already explained you what is the local library, global library, and all these information and all those things, right? So we'll go to that particular section. I have Vaibhav Sugandhi here and plus 5 volt power supply as a project name we have given yesterday. So I'll just click on that. I'll open this particular project by double clicking on the left side of the mouse. Okay, you can see here. This is how the user interface is all about. So first of all, I just wanted to make sure that you guys need to understand one important thing here. It is just not possible for any human being to explain you how to design a professional PCB in just one tutorial. It may be a 2 hours tutorial or 4 hours tutorial. It is not just possible. But what I can do is I can guide you to design a simple schematic diagram and also design a simple layout diagram so that you can understand the protocol, so you can create your own circuits after this tutorial. For that matter, what I wanted to say is make sure that you focus on the protocol, not on the result. Okay. Of course, it is not possible for you guys to create such a beautiful schematic that I can create. Why? Because I'm in this particular tool from more than 2 to 3 years, and day in, day out, every day in our company, we are using the same tool. When you guys are using it for just today, and I cannot expect the proficiency in you right now. Okay. Of course, if you are already a PCB designer before and you are attending this session as a extra knowledge to you, then probably you can do much better than me. I really don't know. but as a beginner, I don't expect you to do that. So that's why don't focus on the result, focus on the protocol or the procedure, because procedure is going to feed you the knowledge how to design a circuit in the later stage of the entire workshop as well. I mean, after this workshop, I'm going to give you a couple of example or a couple of assignment, how to complete them. It is again a part of your protocol. So make sure that you understand the protocol and note it down if it is possible. Great. So first of all, what we need to do is we need to change the name of the sheet. At the bottom of this entire screen, you can see that there is a small option called a sheet underscore 01. I'll double click on that and I'll select the entire name, then change it as a schematic. Schematic, not schematics, as a schematic, okay? Or it's not a schematic, it's a schematic. Okay, so once I change it as a schematic, just hit Control S in your computer so that it will be auto saved. Okay, it is not auto saved. That's why you need to manually enter that Control S so that it will be saved. Okay, thereafter you need to change the title of the sheet as well. See here, there is option for changing the title. Okay, I'll just rename it. Just a second. I rename it as plus 5 volt DC power supply. Okay. I think we can even extend it using, oh, sorry, using 7805 IC. Okay, that looks better to me. And of course, in my case, we have a company name, so I'll give it as for this matter, I'll give it as a UTD, or even we can go with Innovation, not matter. Innovation Private Limited. In your case, you can make it as, oh, sorry, it's not like this. In your case, you can make it as Jain Engineering College, or Jain Institute of Technology in your case. Okay, not an issue. And of course, make sure that your name is visible to here. Because it is essential when you are going to the industrial level of designing some PCBs, it is essential to have this kind of information to understand whether it is designed by you or designed by someone else. Okay, so this is all about the basic setting. After that, I'll hit that Control S, which is very essential. Let me go back to this one. So if you have any questions, please note, guys, you just need to turn on your mic and ask that question. Why? Because I'm viewing our schematic window, so I cannot see the chart window in our this one, Google Meet. So make sure that you turn on your mic and talk to me. Of course, with respect to YouTube people, I'm always checking with the YouTube UI. So no need to worry. If you have any questions, I'm going to answer your question for sure in the YouTube section. Okay, great. Let me quickly jump into the schematic. You can see here. And now I would like to bring the component on the schematic. To bring the component on the schematic, we need to refer our schematic diagram or maybe a circuit diagram presented on the the circuit diagram, PPT. Okay, I just wanted to cross verify whether it is visible. No, it is not visible. Let me share my entire screen to you guys so that you can see the switching between one window to another window quite easily. All right, so it is visible to you now. Wonderful. Yeah, it's visible everywhere. So this is our easy EDA tool, and here we have a circuit diagram with PPT. So first of all, what I discussed is transformer. So we are not using the transformer on the PCB because it is not mounted on the transformer. It is always mounted on the panel. So that's why we need to make sure that we need to use a connector for connecting the output of the transformer. For example, I'll just take that PCB. All right, so I think yep, visible to you, right? So look at it. This is how the connectors are. These are the connectors. Okay, two terminal connectors which we discussed yesterday. These are the connectors. These are the connectors. These are terminal blocks. Usually we use them as a terminal block. These are the connector. So we need to use a terminal block which was having a screw terminal so that you can put a transformer output into these, and then you take that particular track to the next circuit part, or maybe any component that you are using. Okay, so that's why we are going to put a terminal block here. So how to put that? Go to EELib, which is a local library, and then scroll a little bit, you can find headers here, HDR, which are connectors. You need not to use them. You scroll a little bit, you can see there is something called a connector. Can you see this one? CONN-TH, which is a through hole connectors. Make sure that you use a through hole connectors only. No need to use SMD component. In the entire design activity, do not use SMD component at the beginning level. First, you have to understand how through hole technology works. Then later, you will get to know how exactly you can use SMD component. Right now, it is all about through hole. Okay, so I'll select a 5.08 pitch, which is a third option in this. When you click on that small arrow button here, you can see that particular option. I'll click on that. 2-pin connectors is required to us. Why? Because we have a transformer with a 2-pin output. Okay, so I'll place that. And whenever I want to rotate the component, you can see here P question mark is a designator. So whenever I want to rotate this component in either way, like in left side or right side, or clockwise, anti-clockwise, use a space bar on your keyboard. So whenever you hit a space bar, it will rotate in the direction that you are expecting it to be rotated. So I'll rotate it and I'll place it like this. So here we are going to connect the transformer. Thereafter, what is the next part of the circuit? We have a bridge rectifier. So now, as I already said, you can use a bridge rectifier directly as an IC, or you can always use individual diodes for connecting or making a circuit like a bridge rectifier. Right now, I think for sake of simplicity and as you are a beginner students, so I would like to go with creating a bridge rectifier directly, using a bridge rectifier directly. So where we can find a bridge rectifier, let me search in my local drive. There is something called a diode here. You can see here 1N4007 diode is available. So let me check with the diode. Is it available with us? I don't think so it is available because there is only diodes are available. What about the bridge rectifier? Do we have any bridge rectifier here? All right, so we don't have. So when we don't have a bridge rectifier in the local drive, what we need to do? We need to click on global library. So here, what is the bridge rectifier? Either we can type a specific part number of the bridge rectifier that you are interested to use. But right now, as you are a beginner, I don't think so you are having any knowledge about specific part number. Instead of that, what I will do, I'll type it as a bridge. So I'll type it as a bridge only. You can see there are so many bridge rectifiers are visible to you. You can see here the 4-pin bridge rectifier available. And if you see here, this is again completely different. This is a half-wave bridge rectifier. I'll search for a couple of them. I can go to user contributed. I can go to system. Okay. Now you can see here. Look at it. This is the bridge rectifier that we are expecting. Yes or no? I'll search for the few others. I'll not just go and select anyone that is visible to me. This one looks better to me because it has a plus and minus symbol and AC symbol indicated on the other side. So this particular bridge rectifier helps terminals very easily. So I'll select this one and I'll place it somewhere here. So look at it. The direction also matters to us. Minus is here and plus is here. AC input here, AC input here. So we need to connect this one like this one like this. How we connected in this particular circuit. So look at it as a bridge rectifier. So cathode and anode of the 2 diode is connected to AC. And here also cathode and anode of the 2 diode is connected to the AC. Wherein anode is connected to the ground, cathode is connected to the output, which is a DC voltage, pulsating DC voltage. So you make sure that cathode is connected to positive, anode is connected to negative, and cathode and anode is a one AC terminal, and anode and cathode or cathode and anode is another AC terminal. So having said that, we are ready with the bridge rectifier. Now what we need to do is we need to bring a capacitor here. So how to bring a capacitor? Okay. I think I'll just check with the comments if there is any comments or anything. Nothing in YouTube also, so nothing in my this one also. That's a great thing. Wonderful. So we need a capacitor, right? So I'll go to software again, and if I scroll down a little bit, you can see 4 types of capacitors available here. One is a ceramic capacitor, another one is a silica capacitor, another one is electrolytic capacitor, another one is tantalum capacitor. So for your understanding, I'm not going to explain you all these things. Instead of that, I'll recommend you to use a ceramic capacitor with having an arc on the negative side. So I'll just select this one, and I'll select a specific footprint like C, electrolytic, TH. You can see the difference between through-hole technology and SMD here. You can see TH here, right? So this TH indicates it's a through-hole component. SMD indicates it's a SMD component. Right now we are working on through hole technology, so that's why don't use SMD
Then you
component, use only through hole technology. So in this particular case, I'll go with selecting a 8 mm diameter capacitor. Why 8 mm diameter capacitor? We need a 35 volt capacitor here, 470 microfarad 35 volt. So 470 microfarad 35 volt capacitor is little bit bigger one. It is not a small thin one, it is little bit bigger one. For that reason we are using a little bit bigger footprint or maybe a symbol which will help us to place that component on the PCB. Like this, you can see here. This particular terminal block, however we are placing the same way, we need to able to place the capacitor as well. That's why we make sure that we will be using a proper footprint. So coming back to the schematic diagram, we have to select the D8 through hole capacitor here, and then click on that particular component and bring it here and rotate it as per the requirement. In my case, we need to put the plus symbol on the top side and the ground symbol on the bottom side. So I'll rotate it. Now it is possible to place it here. So after placing the component, it is always a good practice to change the value of the component immediately, because it is normal tendency that we are forgetting how to change it or maybe when to change it, all those things, right? Instead of that, it is better to change the value immediately. So 470 microfarad, micro is not possible in a keyboard, so we are using a U symbol, a small letter U symbol, capital F, which is a farad, and a forward slash, then we are going to write a 35 volt, which indicates it's a 470 microfarad 35 volt capacitor. Okay. Thereafter, what we have? Ceramic capacitor, 0.1 microfarad ceramic capacitor. So ceramic capacitors are available here. You can see here, and you can select RAD01, which is a true hole technology again, or if you want, you can select RAD02 as well. But right now, I believe RAD01 is sufficient for us because it is 0.1 microfarad and it doesn't have any polarity. So you just rotate it and place it here. We need two of them, right? So I'll just place one more after that as well, and I will rename them, or I'll change the value of the capacitor by double clicking on the value, and I'll make them as 0.1 small u capital F. There is no voltage for these. Generally, there is a voltage for the ceramic capacitor as well, but right now we'll not consider the voltage. Similarly, for the other capacitor, why it is not working? 0.1 microfarad. Wonderful. So we have two capacitor here and one electrolytic capacitor. Only thing that is left is 7805 regulator. Okay, I'm going to search 7805 regulator in the local library like this. There is a filter option on the top side. Search bar is there, right? I'll type it as 7805. Wow, we can get the 7805 in the local library itself. So what I'm going to do is I'm going to select the through hole technology. SOT is again SMD component. Do not use SOT component. Instead of that, select the TO220. TO220 is a footprint which is used for through hole technology. So I'll select that and I'll bring that component as well. And I'll place them in between these two capacitor. I think we need to place it a little bit wide because I need a proper space for connecting the regulator. Okay. So these are the component. Do you think we are done with the component? Do you think we are done with the component? Or is there anything else we need to bring in? Can somebody tell me, is there anything else we need to bring in? Yes? Come on, guys, talk to me. I just need some response from you. Now we are done with everything with respect to schematic diagram. Do you think we need to bring any component? Prajwal said no for that. Can you explain, Prajwal, how you are saying no for that?
Sir, all the components are placed, but we have to place a power supply, right, sir? We have connected for that connectors.
Which connector you are saying?
Two pin connectors, sir, in the front first.
Where? Output side or input side?
Input side, and also we have to put a output side also, sir.
Input side I already placed. There is a 2-pin connector at the input side which I already placed, rotated and placed P1.
Yes, sir.
So now we need to place it for output as well.
Okay.
Absolutely. That's amazing. Good concentration. What about others? I just want to expect a same result from everyone. I mean, same concentration from everyone. That will help you blossom today's learning. So that's why. Are you guys able to say yes for Prajwal's answer? Do you say yes for that? Type yes in the chat box. Great. Amazing. Somebody, Sonika in YouTube, saying, "Sir, not able to find a rectifier." I think in global library you have to find a rectifier. No need to worry about exactly the same rectifier that I have used. You can find any of the rectifier which looks like a rectifier and which is having a proper diagram. You can use that. It is not necessary that you have to use the one which I have used only. Okay. And Pooja is saying a transformer. No transformer, Pooja. Nowhere transformer comes in the PCB. There is no transformer comes in the PCB. That's why we have kept a 2-pin connector at the input. Remember that. So most of you are saying yes for Prajwal's answer. That's a great thing. I believe you guys are on the same page, and I hope you guys are having the same thought process. So let's go ahead with respect to our screen sharing. Wonderful. I think this time I'll share my easy EDA window alone, not necessary to share my this one. Okay, wonderful. Yeah. So we have placed almost everything here, but we need an output connector as well, because whenever you complete the circuit, say for example, you have placed a transformer in this side, transformer input this side, the circuit will convert that 9 volt 1 ampere current into a 5 volt DC, and where you will tap it, where you will use it actually. You cannot leave the normal track here for soldering of wire and all those things. That is not a professional way. Instead of that, we have to put such a 2-terminal connector or a 2-terminal T block, which will help you to connect the external wire so that you can use it for the further activity. That's the reason why we need to use a terminal connector here, not another type of connector. We discussed about the connectors and terminal blocks, right? So we need to use a terminal block. Wherever you want a screw type of information, screw type of mechanical connection, then you have to use a terminal block. Whenever you want to use this black color Berg stick, then you have to use a headers. HDR header is there, no? I'll show you that as well. In the local library itself, you can see here, there is something called header, right? Header -m. All these options are available. 1-pin header is available, 2-pin, 3-pin, 4-pin, 5-pin, 6-pin, 7-pin, 8, 9, up to 20-pin available with the headers. If you want to use these kind of a black color connector, then you have to use a headers. But if you want to use a screw terminal, like a green color one, then you have to scroll a little bit and you have to find for the connector, CONN-TH_2P-P5.2. Okay, I hope you guys are able to connect with my thought process here. Now we are done with the placing all the component on the schematic window, schematic editor. Let's hit that Control yes once again, because if anything goes wrong and if your internet crashes or your laptop crashes, then you should be able to get the saved circuit. So for that, you have to save it, right? So Control yes is always important. Having said that, let me start about connecting these components together, because now we are done with the placing a component. What about connecting them each other? So first thing what we need to do is we need to hit a W key on your keyboard, or you can use a wire tool available here. Can you see the small pop-up window here? Not a pop-up window, it's just a small window actually available here. You can see here, right? So there is a wire tool available, there is a ground tool available, there is a VCC tool available, VCC symbol available, and ground symbol is also available here. You just need to click on the wire tool to connect them, right? You need a wire for that. Or you can use a shortcut on your keyboard, which is a W key on your keyboard. So when I hit a W key on my keyboard, my cursor is getting connected with a coordination. You can see some orange color line or maybe a red color line, virtual line is hand or hooked to my cursor. Can you see this one, guys? Everyone, say yes or no. I can't see a message on chat window. So say yes or no. Anybody?
Yes, sir. Yes, sir.
Wonderful. Thank you. Thank you. So when we get this kind of a cursor attached with the Cartesian geometry, those imaginary lines, that means you are in a wire tool mode. So what we need to do is we need to click on the one end of the component. I just click the right button on the mouse and I started dragging a wire here. Can you see this one? I started dragging a wire, and make sure that you take the wire wherever you want to bend it. Click one more time on the left key of your mouse and then bend it, and then bend once again and connect it to this one. That's how you need to connect the wire from one pin of the one component to the another pin of another component. Are you guys clear with this? Can we expect this to be done from your side quickly now? I'll do it for the ground as well. Not ground, actually, it is for AC. Make sure that you place it on the edge of the component. Do not go inside and come back and connect it. That is a wrong way of connecting. So make sure that you start from the edge of the component. Can you see this one? It's the edge of the component. And when you are ending, you must make sure that I'll show you here. You are starting from the edge of the component, and when you are ending, you must always do it at the edge of the component. If you want to zoom in, zoom out, use a roller button on your keypad, not keypad, on your mouse actually. So one more important topic here, guys, you must have to have a mouse for designing a PCB. Without having a mouse, external mouse, you cannot design a PCB properly. So make sure that you arrange a mouse for yourself. Okay, so we have to roll in, roll out, to zoom in, zoom out, and once you are at the edge of the component, you have to click the right part of the mouse. I mean, right click, not right actually, left button on the mouse. Okay, so that's how you have to create a circuit. But now I'll come up with one more topic here. Are you guys able to do this one? I'll hit a control S and I'll come back to Google Meet and YouTube. So are you guys able to make this connection? Do you have any difficulty doing this? Are you guys able to do this? Say yes or no in the chat window. Say yes or no. We have a 97 people, but barely few people are responding to my question. That's not a good habit, guys. Please respond to me. It helps me to understand whether you guys are listening or not actually. If needed, I'll modify my talk, but make sure that you learn something from this particular tutorial. I'm facing issue in saving my project, sir. Oh, why? What happened? Make sure that your laptop is connected with the internet. If it is not connected, then probably you couldn't save it. If you still face an issue, close the project or close the entire window, close the software and reopen it. That will help you to solve this particular issue. What about others? What about others? Are you guys able to do a circuit diagram as I did? Even with respect to people in YouTube, 40 people are watching in YouTube. Please respond to me in the YouTube chat section. Are you guys able to do that particular circuit the way in which I showed you? Quick, guys, quick. Again, very few people are responding to this question. Oh, Dinesh is already done with the circuit. Oh, Sachin, if you have a problem with respect to placing a component, then please use YouTube link and seek back and check with that video. I cannot spend time on explaining the same thing again. Please check with that YouTube video. All right. So let me jump into the next part of the video. Now we need to connect this particular part or this particular pin of the circuit to the ground of the entire circuit, which is nothing but this particular end of the capacitor, which we know that, which is a ground connection. But instead of doing a hardwire connection, which will create a confusion at this section, see here, when I draw some circuit like this, when I just 1 second. I draw something like this, you can see some confusion here. Are they connected or not connected? You will not able to recognize them. Okay. Instead of this kind of a confusion, what we can do is we can use a symbolic representation. There is a ground symbolic representation at the top side here, or you can even hit the ground key or G key on your keyboard to get a ground option. See here. Okay. G key is not working. Okay. Control G it is. Not just a G, Control G key it is. Okay, so the moment when you hit a Control G on your keyboard, you will get the ground symbol, or you can get it from this particular thing as well. Okay, however, you get it and make sure that you connect the same ground symbol on the one end of the component like this, and the same ground symbol should be used on the other end of the component or on the other end of the circuit. For example, like this. By doing so, it is directly connected internally. I mean, the schematic diagram will understand, or the software will understand, the customer wants to, or maybe the user wants to connect the first pin of the bridge rectifier to the negative pin of the capacitor. That's what the computer will understand by default. So make sure that you use the same symbolic representation. That's the first thing. And the next thing is all about connecting the output of this, which I'm going to do by using a W key on my keyboard. Here again, and and then here again. Now, what about the ground pin? So what I will do, I'll make a common ground connection for all of these, this one, and even for this one. And of course, I need not to leave this particular net as it is. If I leave it, then the software will understand this particular path or this particular connection is something out of ground connection. So that's why you make sure that you add the same symbol that you have used for other ground connection. Okay. So this is how you need to design your first schematic. Hola, congratulations, you have done your first schematic. Now there are so many important steps to be completed to make it professional look. What are those steps? Selecting the entire circuit and making it organized on the top side of the top corner of the schematic, and reducing the sheets size, because it looks very odd, right? I mean, most of the places are empty and our circuit is only available in this particular section, which is too empty. Rather than that, what I will do, I will reduce the size of the entire sheet. So I will just click on the edge of this sheet like this. You can see here it is changing its color from normal dark chocolate to red color or light red color. That means you have selected the sheet, and you can change the width and height here. Can you see this one, width and height? I will change it to let us say, I mean, there is no standard formula for that. I'll just give a trial and error now. 600. Wonderful. 600 is suitable in the width size. What about the height size? Let me go for 400. 400 is good enough. There is no problem. The 350. That is much better. See here. This is how your circuit should look like. This is professional and very much organized, very much simple, and best at it's possible in the tutorial. Can you guys able to do this one? Save the circuit after doing all these things. Can you guys able to do this one? Say yes or no in the chat window. Say yes or no in the chat window. Quick guys, quick. Do it fast. Already we are at 12 o'clock. Oh my God. There are a lot of things to discuss with respect to PCB layout. Quick. Of course, I'm not going to skip any information just because we are running out of time. Page adjustment yet to be done, Ragraj. Do it quickly. As I already said, it's just all about selecting the edge of the entire page, which is like, hovering your mouse cursor on the edge of this particular line. Click on that, left click on your mouse. Then probably you will get the width and height option at the right side of the entire window, where you change it to 600 to 350, probably, if you have done it so neatly as I have done. If you are done it a little bit wider, then no worries. You can adjust your size as per your requirement. Quickly, do it. What about people on YouTube? I think I can see only 2 responses on YouTube saying yes for that. What about others? Why? Okay, so I'll be going with the next procedure. So please complete this procedure quickly. This is all about creating your first schematic. Congratulations, you guys have created a first schematic of your own. Of course, there are one more important thing to be discussed here, which is all about organizing this entire schematic sheet to the origin. Here is the origin, right? I think you guys are able to see this origin here, but our schematic diagram is very far from the origin, which is not good practice. So 2 things we can do here. We can do it by 2 ways, either dragging and dropping this particular schematic sheet to the origin as quick as possible. But I recommend to go with, there is one more method, which is all about place. If you go to the place section on the top side in the tab section, then there is something called set canvas origin. In the set canvas origin, by coordinates by mouse location, click on the by mouse location, and then click your mouse location at the bottom corner of your schematic sheet. So like this, then your schematic sheet is organized at the origin. This is the most easiest way of setting your origin at the schematic. I hope you people are able to do this as well. Yes or no? Say yes for that if you are done.
Sure.
Of course, say yes if you are done. Just because I'm asking, don't say yes for that. If you are done, then say yes for that.
Done, sir.
Wonderful. That's a great thing. Good. Amazing. So let's jump into the next part of the story, which is all about assigning a footprint. Now you are done with the schematic symbol. Now let's talk about the footprint. What is footprint? Basically, footprint is a mechanical organization on the PCB for keeping the component and soldering it. Say, for example, I would like to say this one. You can see the bare PCB here. If I want to solder an 8-pin IC here, the IC, whatever available in the market, the size of the pin or the width from one pin to another pin or the distance from one edge of the IC to the another edge should be matching with our PCB drill holes. Yes or no? Should be matching with the drill holes on the PCB. Otherwise, you will not fit it, right? You have to bend it, you have to struggle a lot to fit it, which is not at all a good way to do it. As a professional PCB designer, you must make sure that the moment when you bring that component and place it on the drill holes, it should sleekly fit into that particular drill hole. Easily should be fittable or easily solderable on the drill hole. That's how we create a footprint. Footprint in the sense it is the mechanical organization of the drill holes on the PCB so that you can solder the component whichever you desire. Okay. For example, this connector P1 connector, you guys are able to see P1 connector, right? So P1 connector is having a distance between one pin to another pin as a 5.08 mm. 5.08 mm. So the footprint should have a two drill holes which are apart from each other with a distance of 5.08 mm. Yes or no? If it is 4 mm, do you think it is possible to fit the component? If it is 6 mm, do you think it is possible to fit the component? I need a quick answer from everyone.
No, sir.
Yes, I think everybody is having same thought process, right? Yes or no, guys? Do you think it is possible to place the connector on this PCB with different dimension of the drill hole? Is it possible? Not possible, right? Exactly. It is not possible. Yeah, it's not possible at all. So that's why what we need to do is we need to always go and check the footprint right now. Symbols are already done now. You people are very familiar with the symbols now, symbolic representation in the schematic diagram. Now what about the footprint? So how do you get to know what is the footprint of this particular component before purchasing the component? Even after purchasing the component, it is very difficult to measure the distance between one pin to another pin. Even if you try to measure it with a vernier caliper, as a human, we tend to make a lot of mistakes in the measurement process and all, right? That's why there is something called a data sheet. Okay, it's like horoscope of the entire component. Whatever the information need to be given to the user of that particular component is given in the data sheet. So data sheet are going to help you a lot in that process. But right now, I'm not going to jump into the data sheet and give it to you. For right now, I'm going to say you one more important thing. If you guys are interested to learn about data sheet, if you guys are interested to learn about the detailed procedure of creating a symbol and a footprint and all those things, then you can check my other tutorials linked to Frequency YouTube channel, which I'll talk to you later if you are really interested. But right now, I'll not go through a data sheet and explain you how we are getting that particular information. Instead of that, I'm going to use my experience and I'll explain you. First of all, this 2-pin connector is having a 5.08 mm pitch. So I'll click on the component like this. You can see that I have selected the component and there is something called footprint in the custom attribute section. I hope you guys are able to see this one. When I click on the connector window, I mean, wherever the connector is written, after that footprint, there is one small box. If I click on that left key on your mouse, then you can see there is a footprint manager. In this footprint manager, you can see that the footprint assigned to this particular connector is like this. Whether it is right one or wrong one, how to verify? You can click on this pad size, just click on that, and you can see it is arranged with the 5.08 mm pitch. A1 is 5.08 mm. That means it is the right one. What about the pad size? 2.4 mm, 2.4 mm. That's a good one. And drill hole is also 1.6 mm, 1.6 mm. Why? Because they are power electronic connectors, which handles up to 5 ampere of current. Because of that, they need a little bit bigger pad size and all those things. Okay. Drill hole is also a little bit bigger one, 1.6 mm drill hole. What about the capacitor? Of course, we have a capacitor here. See here. We have a capacitor. What is the distance between one pin to another pin? Again, click on the pad size, click on the mm option here, and you can see it is 3.5 mm, which is sufficient. As per my knowledge, for 35 volt capacitor, it is sufficient. What about the ceramic capacitor? Pad size, click on that, and the size of the footprint or maybe the pitch between the two drill point of the footprint is all about 2.54 mm, which is absolutely perfect. I personally believe it is the right one. How you get to know that? It is from data sheet. Right now, you just need to think about it. Thereafter, we have a connector again, it is also 5.08, wonderful, that is a good one. Another connector 5.08, that is a good one. When it comes to 7805, we have this particular footprint here. The most important thing with respect to 7805 is one pin to another pin, it is always of 2.54 mm, which is a standard size. So we have a 2.54 mm pitch between one pin to another pin. That means this footprint is also a good one. But the problem is there is no footprint for bridge rectifier. Oh my God, this is the problem now. So how to search for the footprint and assign it? You need not to create by yourself. You need not to headache yourself to create one more footprint. You just need to search for the global footprint, which is created by creators like me or maybe anybody else on the world. So what I will do, I'll type as bridge rectifier. If you know the exact part number, oh, sorry, rectifier. If you know the exact part number, that would be very easy for you to assign the specific part number. But right now, if you are not having that particular information, no worries. Just type a bridge rectifier here, and in the classes section, change it to user contributed or system or a follow as per your requirement. In follow section, we have a 33 result. In LCSC section, we have only one result. Click on this, but it is not a bridge rectifier. It is a SMD component. Look at it. If it is giving a red color pad and all, then it is SMD component. As I already said, we are not going to use SMD component. That's why I'm not going to use this one. Instead of that, I'll change my classes to system and wait for a few seconds. It needs internet actually. I hope my internet is not lagging. Oh my God, is there any problem with my internet? All right, there is no problem, I believe. Yep. Here it is. You can see here on the first section we have something bridge rectifier, 4-pin bridge rectifier with a symbolic representation and everything. That's amazing. That's a good thing. But if the second one is a little bit kind of icy, which I don't like right now, I'm searching for the round one actually, not the square one. Okay, so let me search. Keep on searching one by one, one by one, one by one. No. So this is a little bit of searching activity if you don't know the specific footprint number. Wonderful. This is what we wanted, right? The round one, which I expected. So you can see the round one is available here. I'll also check with other footprints. If there's anything even more better than that, then probably we can use it. Okay, there is one thing which is looking good but not so good. So I'll go with the round one, this one only, because this is looking good to me. And again, with respect to size of the component and all, it is a 200 ml, 200 mil, which is nothing but a 5.08 pitch from 1 point to another point, which is absolutely correct one, industrial standard it is. So I will select this one and I'll click on the update part here. When I click on the update part, you can see that the footprint is assigned here. Schematic symbol is not yours, footprint is not yours, but you can still use them. Globally designed as footprints and schematic symbols, you can use them for your design. That's the beauty of EasyEDA. It's an online tool and it is helpful for beginners to design their own circuit for the first time. Okay, so once you are done with that, you just cross verify here. All the components are assigned with a footprint. If it is not assigned, then it will create a red color mark on that particular component. Right now, there is no red color mark. That means we have assigned all the footprint with respect to the component. Are you guys clear with this? Till here, once you're done with that, hit that Control yes on your keyboard. Are you guys clear with this? Till here? Yes. Are you guys clear with this? Assigning the footprint process?
Okay.
Wonderful. What about others? Come on, guys, come on. Try to answer my question quickly because we are running out of time. You should have some energy. Type that yes, a long yes, very quickly. Great. Amazing. That's a good thing. I can see a lot of you are responding yes for that. I believe you guys are able to cope up with the speed that I'm going with. That's amazing. That's really amazing. Let me jump into the next procedure. Now you are done with schematic work. Congratulations once again. You are completed with the third step. 1, 2, 3. Third step. Okay, so you are completed with the third step and you are jumping with the fourth step. What is that fourth step? All about creating PCB layout. That's amazing. Let's jump into that. check with the design tab available on the tab section on the top side. Can you see this design tab? And there is something called convert schematic to PCB. Can you see this one? Just click on that. Once you click on that, it will convert your entire PCB into schematic window, and this kind of window appears to you. This pop-up window is very essential, so do not click on apply or cancel at the first moment. Just wait for my instruction. This pop-up window should come to you at the time when you click on that convert schematic to PCB layout. Are you guys able to see that? Are you guys able to see that? Say yes or no. Say yes or no. Okay.
Yes, sir. Sir, it is showing no schematic in the project. Like that, it is showing, sir, when it is clicked.
No. I think that means you have not saved this project, I believe. Check with that. You should go to this particular project window, and you should go to that particular section where you have saved it. There should be schematic. You must have modified this name as a schematic, and it should be reflected here. Have you done that? Is it visible to you? If it is not visible, then you have done some protocol mistake actually. So please check with that. Okay, that's what I'm saying, guys. Make sure that you follow the standards, follow the protocol first of all, because result is not so important for us right now. The procedure, what you are learning, is important, because if you learn the procedure, you can create hundreds of circuits here and after. If you only focus on the result of today's workshop, then probably you will end up designing only the circuit of today's workshop, not about creating a multiple circuit here and after. Of course, there is a recorded session which is available on YouTube, but do remember, you must not spend your one more day for understanding the entire video. Rather than that, please make a note of your own and try to understand the protocol most importantly. Okay. Okay, so we need to go back to this one. Yeah, here. So where it is. Ta-da. Okay, tools, set board outline. Okay, this kind of a window should be visible to you the moment when you click on schematic to layout. Are you guys able to see this one? Are you guys able to see this one? Pop-up window up here. That's amazing. That's amazing. In YouTube also, most of you are saying yes for that. That's amazing. Not most of you. Yeah. Yes, Rekha. Rekha, you wanted to say something? Okay, no, for what actually it is? You are not able to see that pop-up window. Talk to me directly. It's not such a big meeting as well, so talk to me directly. Okay, so I think again, for you also the same answer. Like Prajwal, you have done some mistake with respect to protocol, I believe. So let me quickly go back and share it to you. This is the last time, guys, I'm talking to you. Once you're done with the schematic, you must save the schematic as a schematic at the bottom side. You have to rename this sheet_1 to schematic, and you have to save it. Make sure that in the project section, in the project section of the left side vertical tab, you must be able to see that project, and there should be a schematic within that. If you have not selected the file, new and project option when you have created yesterday the project, then probably you have made a mistake. That's what I'm saying. Do not skip the procedure. Yesterday's video, I clearly mentioned how to create your project for the first time. So if you have not created a project, then probably it will not pop up a schematic window to PCB layout. If you have done that mistake, again, you have to create the entire circuit once again with respect to the same procedure which I discussed in the previous video. So having said that, let me jump into the next procedure, which is all about here. When we come to this particular window, we will be having some pop-up window here. Before that, you can change the units, the canvas attribute here. So change the unit, hit that escape button on your keyboard, which will disappear, which will make that pop-up window to disappear. And then you click on this particular unit section and make it to mm, because we Indians are very much comfortable with the mm rather than mils, which is used in Australia most of the time. Okay, that's why you just change it to mm so that you can understand it very easily. Thereafter, go to the tools section and click on the set board outline, which is absolutely the same pop-up window which appeared to you for the first time when you converted from schematic to PCB layout. Now what we need to do is we need to start the entire PCB size from 0,0 axis, which is very important, right? So I'll make a start X as a 0 mm. Okay, there is a num lock on my keyboard. So and a start Y as a 0 mm. And when it comes to width and height, it is giving some random number here, 53.340, and height as a 35. Right now, even I don't know what is the size of my PCB. So what I will do, I'll make it as a 50 round figure, and 35, which is a round figure again, not 350, 35. So then click on the apply button. So the moment when you click on the apply button, you can see your schema, your layout is ready for going with the PCB layout. You can just drag and drop the component outside the PCB border. This purple color, whatever you are seeing, it's a PCB border, and the component should be outside. You can drag and drop one component one by one, or you can select them all together and drag them outside. Make sure that you do not select the border while dragging the component, because it will disturb the size of the PCB. Okay. So here, what we need to do is we need to follow the standard of our circuit diagram. What we have done here in the circuit diagram, P1 is kept at the left side of the entire PCB, or left side at the entire schematic diagram. So I'll select a P1 and I'll come back here. Of course, it will not reflect. Why? Because we have not saved this particular PCB layout. After doing this much of activity, please hit the Control S on your keyboard. Why it is so important? Whenever you click the component here, it will be highlighted in the layout section. See here. Can you see this one? P1 is highlighted. You have a very little component, so we can easily identify where is the P1, where is P2, and all those things. But when it comes to a little bit large circuit where you are using more than 10, 20, 30 components, on that time searching P1, P2 is very hectic process. Instead of that, we as a humans and as engineers, we can always go with the shortcut method, or we use our brain for that particular sake. Okay, what is that process, or what is that protocol, or the shortcut is all about selecting the component in the schematic and coming back to the layout window. There you can see it is having highlighted. Okay, what we need to do is we need to place that particular connector on the left side. Why? Because we have kept it on the left side in the schematic. We have to follow the certain standard here, industrial standard, right? And then we have a bridge rectifier. I'll select it here. Wonderful, it is highlighted. And now I'll place it somewhere here. Right now, let's go ahead with the procedure. I'll select a capacitor and I'll come back here. You can see there is a capacitor. I'll just rotate it by using a space and then place it somewhere here. Then we have a ceramic capacitor. I'll select the ceramic capacitor, place it somewhere here again, and then we have a bridge rectifier, not rectifier, linear voltage regulator, which I'll placing like this right now. I'll tell you what is the reason for that. There is one more C3 capacitor. I can place it somewhere here. That's again amazing. Thereafter, what we have, P2 connector. So I'll just select a P2 connector and place it somewhere here. Okay. Now this particular circuit is placed. The components are organized in the same way how we did in our schematic diagram. Of course, in the schematic diagram, we did it with a little bit space and all. In your case also, if you want to organize it in little bit spacious, then you can go back to tool section, set board outline, increase the width of the PCB, which is 50 right now. I'll make it as a 60. That's quite simple. See here, another 10 mm we got here. I'll extend the size of the PCB now. And I'll just increase the placement of the component. I'll just place it like this right now. Let's discuss about it later. Okay, like this. Okay. Now the most important topic comes here. Just before that, I just wanted to cross verify. Are you guys able to hear me? Are you guys able to hear me? Screen visible to you? My video is visible to you? Yes, right?
Yes, sir.
Okay, great. Thank you. Okay, all right. Okay, so the most important point here is how to organize these components. In the schematic, how we rotated the component when we are connecting, what happened? Okay, here. When we are connecting these components in respect to this particular connector, we did the rotate option, right? By using space key on your keyboard. The same way with respect to this particular layout, we have to rotate the component as per the requirement. What is the meaning of as per the requirement? you should make sure that the copper, whatever you are connecting on this PCB layout, should not overlap each other. If it is overlapping, then it is a short circuit, yes or no? If you are connecting the output of the bridge rectifier upon that particular input signal, then obviously you are short circuiting input and output, because it is single layer PCB. We are using only one layer of copper. So that's why you should make sure that you rotate the component according to the requirement, so that you cannot have a overlapping connection. Okay, right now I'll go with something like this. We have a connector here and we have a bridge rectifier. I'll rotate it, and you can see that here. So the negative is connected here, but positive is connected here, which is a little bit contradictory to me. So I'll rotate this one. Whatever the blue color imaginary line you are seeing here, they are called a rat nest, by the way. They are the guiding line for you to think how to take that track. So you have to connect from this point to this point. That is what that blue color line is saying. You have to use the bottom copper and you have to connect it. But how to connect it, it is your choice. I mean, you can rotate this component and connect it. Look at it here. It's quite easy for us to do that right now. You can see here. Okay, you can do like this also, or if you want, you can do like this also. Make sure that those blue color, imaginary blue color lines are not overlapping as much as possible. It is not possible to achieve 100% accuracy in this process. We have to struggle with the routing part and all. But right now, make sure that you do not have a overlapping blue color line, because it is a very simple circuit, small circuit. Thereafter, what we have this capacitor. So I'll just check with this. I think we need to rotate the IC as well. That will help us to. No, I don't think so we can do that, because input will go on the left side and output comes on the right side. That is not the right way. So input should be on the left side, so that we can connect the input section to that particular thing directly. So I'll place the ceramic capacitor like this. That would be very helpful. And the output side also, I'll just make sure that it is connected like this. Now we have a cross here, right? Can you see this one? There is a cross on the blue color line. How to solve this? I'll rotate this connector. It's solved. Okay. Like this, you have to organize the component. I think I have organized the component, and I can reduce the size of the PCB, or I can arrange the component in a little bit inside fashion like this. You can select all the component, use arrow key on your keyboard, and bring it a little bit down, and then a little bit upside, so that we can save a lot of space on the bottom side. Okay. And one more important thing, these kind of regulators, whatever linear voltage regulators you are using, they should be faced outside. Why? Because there should be a heat sink, right? If it is heating up, there should be a heat sink. If you are connecting a heat sink inside faceward, then it is going to cause a heat problem with the other components in the entire PCB. If you want to avoid such kind of a problem, which is a non-international standard, which is a wrong design basically. To follow the international standard, you have to make sure that you have to keep the heat eliminating ICs on the outside edge of the entire PCB. That is the most important standard you have to follow. Right now, I'm done with the placing component. How many of you are done with the placing component? After placing the component, hit Control yes. How many of you are done with the placing component? Do it quickly. I'll give you 3 minutes. Do it quickly. Okay, great. I can see so many of you are saying yes for that. That's amazing, actually, guys. You people are learning much faster than what I expected. That's a great thing. Amazing. Pushpak, you wanted to say something? Pushpak Kumar, you wanted to say something because your mic is turned on.
Yes, sir. I couldn't open a project, sir. So I can't.
Okay. Have you done the same protocol as I said? Go to File, create a project. Have you done that, or you have clicked on the schematic section?
No, sir. I have created the project, but it says that it's an error. So.
Are you doing in local client version or in the web editor?
In these apps, Easy EDA app.
No, I know that in the Easy EDA app only we are working. But my question is, are you doing it on the website directly, or you have downloaded the software and installed in your computer?
I have downloaded the software, sir.
Are you using a Mac operating system? Are you a Mac user?
No, sir. Windows.
Then why, man? What is the problem? Okay.
I don't, sir.
Please check with creating one more project and quickly creating a circuit. Probably that might work. Or close the software and reopen it. That might work as well. I have not faced such issue before. That's why I am also a bit confused. Check with that.
Okay, sir.
Yeah. Okay. Thank you. All right. So most of you are saying yes for that. In the YouTube as well, most of you are, not most of you, I mean, very few people are responding YouTube. I really don't know what happened with you guys. If you're responding YouTube also, I'm looking at it. So try to respond in YouTube as well. That helps me to know whether you guys are on the same page or not. Okay. Great. Wonderful. Let me go back to my software, which is a ZDA. Okay. Now the time is to create a track. We discussed something called a track width yesterday. How many of you remember with that? What is a track width basically? What is the use of track width? Can somebody tell me what is the use of track width? Okay, Venkatesh is saying I'm a Mac user and it's working properly in Mac. That's amazing, Venkatesh. If there is no problem with respect to Mac user, that's amazing. I don't know what is the problem with the Pushpak. So let's see that. Amount of current flows in the track. That's amazing, Nagraj. Whatever you said, it's pinpointed. Current flowing through the track width. Sai, your sentence is grammatically mistake. It's not a track width. Current is not flowing with the track width. The current flows with respect to track width. If the track width is higher than 1 mm, then more than 1 ampere of current can be flowed in that particular track actually. Okay. I think all of you are having the same definition in your mind with respect to track width. Keeping that in mind, I would like to go ahead and think about it. So in our PPT, we have already discussed, we have a transformer with a 9-volt 1 ampere. I hope you guys are remember with that, right? So now tell me, if it is a 1 ampere transformer, what should be the minimum track width of my PCB track that I'm drawing? Because it should carry at least 1 ampere, yes or no? And there should be some factor of safety and all. So it should be at least 1.3 ampere because we use 30% as a factor of safety usually. So track width is directly proportional to the current flowing. Absolutely true, Sai Suchit. Directly proportional to the current width. Yeah, correct, Vimarsha. Okay, correct with your answer. So now tell me, what is the minimum current that we have to create? I mean, what is the minimum track width we have to create for the 2-pin terminal or throughout the PCB? Which is at least 1 ampere, which is at least 1 mm track width. Why? Because we have at least 1 ampere of current rating. Okay. Having said that, how to create a track now? We need to make sure that we are on the bottom layer here. Can you see this one? Layer and object option, or there is one tab which is all about layer and object. There is a red color which is a top layer. There is a blue color which is a bottom layer. Make sure that you click on the bottom layer before designing any track, because you are using a single copper, which is all about single layer PCB, single layer, single sided PCB, because we are keeping all the component on the top side and we are using a bottom copper alone. We are not using a red color copper, which is a top copper. So that's why make sure that you click on the blue color before jumping into creating a track here. If you have not clicked on the blue color, then probably you will get a red color track, which is wrong, which is absolutely wrong. Do not use a red color track at this point of time. So once you click on the bottom copper, again, same procedure, hit the W key on your keyboard, and you can see there is a Cartesian geometry is attached to your cursor, and you just need to use that one. I'll click on the one part of the component here, and when I drag a little bit, you can see there is a small track connected to it. Of course, that track width is not 1 mm. How to change the track width on the go? You click on the tab section on your keyboard. So once you hit a tab section, there is one more small pop-up window appears to you, which talks about attributes, and it is having a track width as the variable. So it is currently using 0.254 mm. We need to change it to 1 mm. Okay. The moment when you change it to 1 mm, notice how track is increased. From previously it was so small, now it is so big. So you have to use this specific track width for the entire PCB. Why? Because we are using 1 ampere transformer. Are you guys clear with this? Start creating a circuit or start creating a track width like this. It's quite simple actually. Just click right click, left click on your keyboard. The way how you created the wire in your schematic diagram, the same thing you have to do with respect to PCB layout. Only the difference is there it is just a thin line, here it is a track width. It's a pure copper actually that you are drawing on the PCB. Okay, go ahead, try to do it fastly. I'll be finishing it like this. Ground also will take care later. Right now I'll finish with respect to input here, and I'll finish it with respect to input here, and then output here, which is like this, and then I'll make a connection to this, or maybe this one. Okay, so drag and drop here, drag and drop here, drag and drop here, and there is only one connection left here. What I will do is I'll try to connect it from the other way, like this. Now I just wanted to give you some information here. Are you guys able to complete this much? Complete this much and say yes in the chat window. Once you're done with that, say yes in the chat window. Done. Okay, that's a great thing. What about others? Come on. Yes, sir, completed. That's amazing, Sagar. What about others? Come on, guys, come on. Amazing. So some people are responding in chat window of YouTube as well. That's amazing thing. Nagaraj, why you are lagging behind? I really don't know, but grow up, man. So when you are connecting this track, when you hit a W key on your keyboard, making sure that you are in the bottom layer, when you hit this particular point, when you come out of that point a little bit, do not connect it to the other point of the component, just hover it in between. On that time, hit a tab key on your keyboard. So the moment when you hit a tab key on your keyboard, you see a small pop-up window which talks about attributes. In that, you have option called width. Here, generally, it is 0.254 mm. Change it to 1 mm. That's it. Very simple it is. Come on, guys. Come on. Done with everybody. Everybody, please respond to me. 89 people in Google Meet. Please respond to me. Are you guys able to do this one till here? Because there is one more important point which I'm going to discuss here and after, which is absolutely important. That's why I'm asking. Amazing. What about others? Only 5 to 6 names I can remember, and I can recall their name while in the chat window. What about others? Are you guys sleeping? Is it a boring class? Is it a boring class, by the way? I just wanted to ask you guys, is it going boring on? Are you guys comfortable with my English, by the way? I'm a little bit talkative person, that I speak in a little bit faster English, I believe. If you guys are comfortable with that, then only I'll continue. Otherwise, I'll change my tone. So do let me know. Are you guys comfortable with my English? Is it boring, by the way? I hope it should not be boring. But still, if it is boring, no worries. I'll try my level best to change my tone, and I'll make it interactive as much as possible. Again, the answer for this question is 1%. So I only said no for that. What about others? Wonderful. If it is more interesting, that's a good thing. I'm happy for that. All right. So I think you guys are on the same page now. Let me jump into the next concept. Okay. So the next concept is all about how to create a track from this point to this point. Can you see this one? There is a blue color imaginary line, which is so-called a ratness, by the way. You can see here, there's something called a ratness here. So if I toggle that I button over there, then that disappears and it will come again, it will go again. So I'll go back to this one and not this one here. Okay, it's so-called ratness. So I'll enable it for your kind information. Now we have a problem how to create this point to this point. Of course, you cannot draw a track from this point to this point directly like this. If you try doing like this, you are essentially creating a short circuit between this particular wire and this particular wire, okay, which is absolutely wrong. We know that, right? How we can create it? Either we can take a wire from the top side and take it to this one, and then this one to this one. This is amazing way of creating it. Can you see that? Yes, we have to find a path for that. This is artistic work, more of artistic work. You have to find a path for creating a track from one point to another point without having overlap. Okay, that's an important concept that you have to learn. Okay, are you able to do this one, guys? Are you able to understand this concept and do it? Make sure that your track is not too much near to this particular border, and also it is not too much near to this component. Okay, this component pad is there na. Yesterday we discussed about two important concepts: isolation and track clearance. Track clearance is all about what is the distance between one track to another track. That is a track clearance. What is isolation? What is the distance between one component to another component? Here you can see this is a small distance between capacitor and the bridge rectifier. This is called isolation. If it is sufficient enough, that is good one. If it is not sufficient enough, you have to make sure that you move a little bit this capacitor like this to make it sufficient enough. Okay, are you guys able to recall the yesterday's basic terminologies that we discussed yesterday? Are you guys able to recall all the concepts that we discussed yesterday? Great. Okay, so having said that, there is something important to be done. Okay, great. So this is all about creating your first PCB layout. Congratulations again, you are a PCB designer. Oh, that's amazing. So now you have designed your first PCB with respect to a single voltage power supply, 5-volt power supply design. There are again some procedures which are professional work that should be done by you to call yourself as a professional PCB designer. What is that thing? After designing the PCB, if you want to mount this PCB on any panel or maybe any board or any plastic casing or something, there should be some mounting hole, isn't it? There are some mounting holes here. All the four sides we have some mounting holes. These kinds of mounting holes are mechanical stability for your PCB to stay inside the product. Okay, have you seen any one of your electronic gadget disassembled, and have you seen some PCBs are fixed on the panel, something like that? Have you seen that, guys? Yes or no? Have you seen that? Okay. What about others? I'm yesterday to do the circuit in my PCB board. Venkatesh, what you're saying, I didn't get you. I am yesterday do this circuit in my PC. Oh, okay. So you have already implemented the same circuit that we are designing today. That's amazing. You might be having a more knowledge than just designing the PCB. That's a great thing. Amazing. So most of you guys are very commonly known to this particular fact, right? So there should be something related to mounting holes. When you are mounting something on the PCB, you probably having mounting holes. How to create a mounting holes now? So I'll talk about that in a couple of minutes. Let me jump into that. Just a second. There is a comment in the chat window. So grounding means it can be able to handle all the current which is given. So in the circuit, what is the material which is used to the can bear these huge voltage? Manjunath, I didn't understood your question, but I feel you are asking some component which will bear all the current that is coming from the circuit. That is nothing but a ground connection, boss. Whatever the ground connection we are doing here, whatever the ground we are designing here, it is going to handle all the current that is coming to the ground point. It's a common point for the entire circuit, right? So that is the place where the all current of the entire PCB is coming and shrinking in the circuit. Okay, that's why it is so called a ground, by the way. All right, so how to place the drilling hole on the edges of this particular PCB? First thing, we need to look at the hole option on the PCB tool section. I hope you guys can see there something called PCB holes, PCB tools. In that PCB tools, you can see something related to a drill hole, which is appearing like this. Are you guys able to recognize this one? just click on that and bring that drill hole and place it on the corner here, and also one more on this corner, and one more on this corner, one more on this corner. All the four sides you have placed the drill holes. Okay, after placing that, you must make sure that all the four drill holes are need to be modified with its dimension. Why? Because by default it is 2.032 mm, but in India we use M3 drill holes, which means 3 mm drill hole. So I'll just modify it as a 3 mm drill hole. No matter how big they are looking in your PCB, you have to maintain the 3 mm drill hole, at least 3 mm. If it is possible, if it is required, we can go for 4 mm as well. I'll select here, I'll make it 3 mm. Wonderful. Now the most important thing is, do you think we just need to place this drill hole like this and leave them without having a coordination between one hole to another hole, without having a proper distance between one hole to another hole? That's not the right way to do the PCBs, right? It is not going to fit on the panel very easily because randomly we are placing the drill hole. We have to make them professionally placed with the Cartesian geometry. Cartesian geometry in the sense using the distance, we have to place them. Okay, so how we need to use a distance? Before that, I need to make sure that my PCB size, outer border should be connected or should be finalized before that. So how we can do that? I'll go to the tool section. I'll click on the set board outline. Width is 60, which is finalized. Height is 35. Instead of 35, I will go for 25. It's experiment, trial and error. Wonderful. 25 is fitting for me. 25 is fitting for me, but in your case, it may be 30, it may be 35. Instead of 60, it may be 70, it may be 80. No worries. In the first time when you are designing, don't worry about it. Just go ahead and whatever the size comes to you, make sure that it is a round figure and you remember it. We know that it is 25 by 60. So now this particular drill hole should be placed 3 mm from the board edge. 3 mm from the board edge. 3 mm diameter drill hole, 3 mm from the board edge. So this is origin part, which is 0,0. So where this particular drill hole to be placed? It is placed at 3 mm and minus 3 mm. Why? Because we are in the negative y-axis. We are not in the positive y-axis. We are in the negative y-axis. What about this particular drill hole? Of course, 3 mm in the negative y-axis, because from the top side, it is just a minus 3 mm. But with respect to x-axis, we have to minus the 3 from the entire width of the PCB. So what is the width of the PCB? 60 mm. 60 minus 3, it is going to be 57 mm. So I'm going to select the drill hole and I'm making it as a 57 mm and minus 3 mm in the y direction. Similarly, for this particular hole, 3 mm in the x direction. Y direction, we know that it is a 25 mm PCB. So 25 minus 3 is 22. So we are going to make it as minus 22. Do not miss that minus sign. If you miss that minus sign, it will go and sit on the top side here. So don't get confused with that minus sign. What about this one? Can somebody tell me what is the position of this particular drill hole on the right bottom corner? On the right bottom corner. Can somebody tell me what is the dimension or what is the coordinate geometry for the bottom drill hole? Can somebody tell me?
57, 22.
Amazing, but your answer is partially right. 57 minus 22. If you make it just 22, it will go and sit on the top side. So it is 57. This is minus 22. Amazing. You are done with the professional PCB for the first time. Congratulations, guys. So this is how you need to design your PCB. After that, of course, not to mention, we need to hit that Control S, and of course, it will ask you, would you like to overwrite that? Say yes for that. Done with your first PCB designing. Done with your first PCB designing. There is one question in the chat window. What kind of a material we use for grounding? Manjunath, it is absolutely copper. There is no material for using grounding. Grounding should be done by using copper pads or copper distribution. So it is purely copper. There is no other material for grounding in the PCB, at least. With respect to people in the YouTube, I hope you guys are able to understand this one and able to do it by yourself. So I think you guys are done with designing a first PCB. How many of you are done with this? Dinesh is saying, yes, sir, done. Hooray. That's amazing. Hooray. Let me have a cup of water. Say hooray in the chat box if you are done with the enthusiasm. If you are just done it because of it's a part of your workshop, then I think you are not so enthusiastic. But if you are enthusiastic, say hooray in the chat box. Let me see that. Even for YouTube people also, you can say hooray in the chat box. That looks very wonderful to me. I love these kind of a thing, by the way, because learning should not be boring, right? It should be something interactive. Prajwal say yes, hooray for that. I think your issue got solved and you're designing a PCB there. What about others? What about others? Only 2 people said hooray for that. What about others? Designing, completed. Kiran says hurrah. That's a great thing. What about you? What about others, guys? Come on, come on, come on. Type hooray in the chat box if you have done with respect to designing a first PCB. Chaga says hooray for that. That's amazing. Done with this. I'll give you another 1 minute for you guys to complete it if you have not completed. Once you're done with completion, please type hooray in the chat box. That makes it a little bit interactive. Come on, guys, do it fast. We are running out of time. Only 10 minutes I'm left with. I think the content, whatever I have discussed, is already pretty much, I have covered everything. There is one more important thing I have to discuss. That's why I'm asking you to type. So do it quickly and type hooray on the chat window. Abdul says hooray for that. Arpita says hooray for that. That's amazing, guys. Cheers for completing your first PCB. I think my sentence need to be updated. Completing your first PCB using Easy EDA tool. Radhika says hooray for that. That's amazing. What about others? What about others? Come on, guys. Why you are so lazy, people? Come on. If you are done with the circuit, type hooray in the chat window. Come on, do it. Don't feel like you are 60, 70 years old, guys. I'm elder than you. I know that, but still, I'm a child inside in my heart. So this is the life. We need to enjoy everything, right? No philosophy, but just expecting some motivation from your side. Hooray! Nagaraj is saying hooray for that. That's amazing. That's amazing. Wonderful. So let me jump into the next part of the entire story, which is going to help you to create a PCB file, which is going for manufacturing. Now I have 2 important things to be discussed with you guys. What is that 2 important things? Okay, let me check with that. Okay, so 2 important things to be discussed with you guys. Now your PCB is ready. Either you send this PCB for fabrication in the fabrication house, as we discussed already. What are the protocols? 7 important protocols I discussed how to create a PCB. First one is circuit diagram, second one is schematic diagram, then comes the PCB layout, then PCB assembly, PCB fabrication, PCB assembly, and board bring up activity. Footprint and layout is also one part of the entire story. So these are the 7 important stages of manufacturing or designing the PCB. So now you have 2 options. Either you can develop a PCB, a single layer PCB in-house by using a chemical process, which is so-called a toner transfer method. In that case, what you need to do is we need to take a printout of this particular software. How to take a printout? I'll explain you. Go to the file section, click on the export, or maybe hover your mouse on the export, click on the PDF. Once you click on the PDF, make sure that you are having all these radio buttons checked. First one is engine, which is a local, graphics, full graphics, type merge layer, and color one black on white. You should not select anything other than that. If you select anything other than that, it is going to mess up with your circuit. So these are the first setting. Thereafter, make sure that you are not selecting a top layer because you have designed your PCB in bottom copper. So click on the bottom layer, and top silk layer also you have to disable it. You don't need other than anything copper. Like you need only bottom copper, so select on that and make sure that your board outline is selected and multi-layer is also selected, and then holes is also selected. Documents and other than these four important things, everything has to be disabled. Okay, on that time click on the export. The moment when you click on the export, it will pop up one more pop-up window where you can save your PCB. I think it is visible to you guys. Let me check. Yeah, it is visible. So in this pop-up window, change the name as per your requirement. It is already PCB 5 volt power supply 2020 2022, whatever. All those things are given there. Instead of that, I'll remove all that thing. I'll keep it as a PCB underscore plus 5 volt power supply underscore plus 5 volt power supply. .pdf is extension. You have to add a .pdf at the end. If you do not add the extension, then the file will be in the JSON format, which confuses you how to take a printout of that. So instead of that, make sure that you type a .pdf at the end. Thereafter, you just click on the save. The moment when you click on the save, it will be saved. So let me go back to screening my entire screen. Sharing my entire screen. Grammatically, I am making so much mistake. I really don't know. Okay, now my entire screen is visible to you guys. Quickly, I'll jump on the desktop. Here you can see the PDF file is visible to you. So just double click on that. You can see a PDF file, which is your circuit. Voila. You can take a printout of this and do the toner transfer method and create your own PCB by using the ferric chloride chemical process by manual. That particular process is again a different story, which I'm not going to cover in this workshop, but I think you guys can do that by looking at some of the tutorials on the YouTube. Otherwise, wait for some time. I'll be creating some tutorial on our new channel, that is a linked frequency, where you can search and understand the detailed tutorial of more than 30 to 40. This particular workshop, I'm not going to talk on toner transfer method. This is a one method of designing your PCB and printing it on the physical layer, or physical copper layer. Okay. Thereafter, let me go back to the software. Now, say the second scenario, you want to send this for the fabrication house. For example, us. For Earth Key Innovation Private Limited, if you send your PCB file, Gerber file or something, then we will manufacture it for you and give it to you. So somebody is speaking over there. Any question, guys? Do you have any question? Rekha, again, do you have any question? You turned on your mic. Do you have any question? All right. So if you don't have any question, let's not waste the time. So if you are sending the PCB file for a fabrication to us, like Earth Innovation Private Limited, and sending it to us for manufacturing it in the green color format like this, the green color one, professional PCBs, then what you need to do is you need to go to File, click on the Generate PCB Fabrication file. There's something called Gerber, which is written in the bracket. You just need to click on that, and it will ask for Chuck DRC. If you want, you can click on yes, Chuck DRC, but if you don't want, then click on no, Generate Gerber file. So I'll just click on the Generate Gerber file. Here you can see that there is an option for Generate Gerber. The moment when you click on that, again a pop-up window appears to you. Here again, what you need to do is you need to modify the name as per your requirement, and then add an extension as .zip, .zip file. Okay. Once you click on that, it will be saved in your local drive, maybe on the desktop again. So here it is on my desktop. It is here. So I'll double click on that. You can see these are the Gerber file. Okay. These are the Gerber file which you can send for the fabrication people and get it fabricated with your PCB like this green color. Okay. These are the two ways to manufacture your PCB. Are you guys clear with this? Are you guys clear with this? Dinesh is saying yes for that. What about others? Come on, guys, have some enthusiasm inside you. In what, I mean, in YouTube channel, I never seen any hooray in the chat window. That's really boring people out there. No, I'm happy that we have a lot of enthusiastic people in our Google Meet. Nothing to differentiate, just for the kidding. Okay. So many of you are saying yes for that. So now you understood how to design your own PCB from the circuit diagram to till the manufacturing of the PCB, either in the local manufacturing or maybe with respect to the fabrication house, which is industry like us. Okay. Now quickly I'll jump into the another part of the entire tutorial. We are about to finish the tutorial, so just wait for another few minutes. We are almost done with the time, but let's wait for another few minutes. Why screen is not visible? Oh my gosh. Just a second. Here it goes. A window. Yes, here it is. Okay, so can you guys able to see my screen now? I hope so. You are able to see that. Can somebody? Okay. Yes. Okay. Thank you. All right. So now I'll just quickly give you one more brief thought process. We started with a 2 days workshop on basics of PCB designing for 2022, and I'm very sure you guys are enjoyed with the process. So as I said in the agenda, we have completed with the basic terminologies of PCB designing and the PCB industry as a whole. Then we created our account in EasyEDA. Some people are having some trouble. Don't worry, guys. It takes some time from your side to debug that particular problem and resolve that error. If you want to contact me, of course, I'm going to give you direct contact number. You can call me, you can WhatsApp me, and you can interact me directly. That particular contact number is going to help you to resolve some of the error if you have anything. Unnecessarily, don't spam me, please. Okay. So we discussed with the introduction of EasyEDA tool and also its environment. Thereafter, we discussed about understanding the design of schematic for the first time, converting circuit diagram into design of schematic, and you enjoyed the process as well. Thereafter, we spoke about importance of symbols and footprint, and we created or we assigned a couple of footprint, not couple of one footprint with respect to the symbol that we have selected in the schematic diagram. Thereafter, we designed our first professionally looking. That's really amazing work for the day. And then we have something called assignment. Let me jump into that. Creating account again, introduction to our tool and all those things. This is a circuit diagram again, and these are the footprints, which are footprint and a PCB symbol, which is absolutely important and essential for any PCB designing. Thereafter, we have something like this. We have created the same circuit, I believe. There is some slight modification in that. Of course, if you guys want to add some logos like this, you can still do that. If you want, you can add your own photo on this PCB. It's quite easy. Import as an image and you can do it. If you want to do that, you can explore that one. That's quite interesting and fascinating part of the entire story. Okay. Now, these are the two assignments which I wanted to assign you to, guys. Please try to work on these two assignments. There is a one dual voltage power supply which has a 12 volt and 5 volt power supply. Of course, it is as simple as whatever the 5 volt power supply we have designed, but there is a little bit extra IC which we have added here. So try to design your own circuit for this schematic diagram and PCB layout. If it is possible, send me your schematic diagram and the layout for verification over the WhatsApp. I'm going to give you that detail as well. Okay. And if it is possible, try to work on creating the stable multi-vibrator, which is one of the most common circuit that we have explored in our college days. So try to create a PCB for that. That is going to be one of the experiment or maybe learning process for you guys. Okay. So having said that, if possible, try to create more and more PCBs more than the circuit that I have given to you, if it is possible. Thereafter, thank you so much for this entire workshop. Here is my contact number. This is my name, Vaibhav Sugandhi, and I'm available on Instagram as well as on WhatsApp. The same number, you can contact me at any point of time. Don't spam me, please. Other than that, you can contact me for any kind of a knowledge, even after this workshop. There is no problem. I'm going to help you in the process of designing your circuit, in the process of reviewing your circuit. Okay. So this is all about our presentation for the day. And there is one small request to you guys. Having said that, do you guys enjoyed the entire workshop? That's my first question. I have a small, okay, already we have a comment that I enjoyed a lot. What about others? I want 98 people in the Google chat. For the last time, asking you guys, try to comment your answer on the chat box. Do you guys enjoy the entire process of designing a single PCB, a single layer PCB? Yes or no? Enjoyed or not enjoyed? Enjoyed a lot. That's amazing. Enjoyed a lot. That's amazing. That's amazing. Thank you. Thank you. Yes. Enjoyed a lot. That's amazing. That's amazing. Amazing. Good. Go ahead, guys. I have 98 people here. At least I expect 50 responses in the chat window. At least. Enjoyed a lot. That's amazing. Vaishnavi is saying yes, sir, for that. Oh, okay. There is a small feedback over here. Ravi Kumar, all of you wait till end of the session for. Oh yeah, of course, Ravi sir. I mean, all of you students, please wait for the feedback session. There is some protocol from college, Jain Institute of Technology College. We have to complete so that you will get the certificate and all those things. So please wait for the conclusion from the college faculty, either from Anusha madam or maybe Rami sir. So please wait for that. But just before that, I just wanted to ask you, did you guys enjoyed it? If you guys enjoyed it, I have a small request to you at the end of this, a big yes, but mess with opening the project. I will. Pushpak, you have a strong problem. I think I have given you mobile number in the slide right now, whatever the screen sharing you are seeing right now. You can contact me directly. Let me see if I can rectify your error after this workshop. Okay. Very informative and led to have a knowledge to the PCB. Thank you, Manjunath, for your wonderful word. I believe you are enjoying the process and you have got to know that how to create your first PCB, and it inspires you to become a PCB designer in the coming days. All right. So having said that, I have a small request to you guys. If you can think about my tutorials are very wonderful. If they are really good for you to learn, then I'm going to create a lot of tutorials like this for free of cost on our YouTube channel called Linked Frequency. So in that case, you can subscribe to our channel over there. You can type Vaibhav Sugandhi or a Linked Frequency in the YouTube, and you'll get to know that logo, whichever logo we have, right? So in the first slide, we have a logo. Where it is. Okay, I think here it is. On the first page, we have a logo here, right? So this particular logo channel is there. If it is really wonderful for you, I'm not forcing you to do that. There is no sales call or all those things. If you really find it useful, whatever the tutorial I have connected, then we are two people who are trying to create a free tutorials for young people like you. Whatever the industry knowledge that we have gained in the last 6 years, we are trying to post it in the form of free tutorials in Linked Frequency channel. So try to subscribe to that and get more knowledge about PCB designing, Tinkercad, and Arduino Uno development board. Even recently, we started with artificial intelligence basics for beginners. Okay, so you can do that. Oh, already subscribed? Thank you so much for that. Thank you for the response. Okay, there are some comment, I guess. Let me look into it if it is necessary to discuss. Okay. Big yes, but messed up. Okay, that I have read. Navya said enjoyed a lot. Great, sir. Even informative and led to have a knowledge to a PCB. That's amazing. Enjoyed. Learned something new for explore in our future. So yes, of course, Prajwal. Yes, of course, Prajwal. You can use this particular skill to form your entire career. It is possible. Just make sure that if you can do it, then try to do that. If needed, I'll guide you personally. If it is required, I'll personally guide you. Contact me over WhatsApp or maybe in the email, which I already given to you in the previous tutorial. So you can contact me in the process. Okay. All right, so I am done with everything that I have to do here. So anything else we need to do here, guys? I believe there is nothing else left from my side. I'm done from my side, whatever is required. So even in the WhatsApp, not in WhatsApp, even in with respect to YouTube live streaming, Kirtana said enjoyed a lot for that. So many, 3 of you said enjoyed a lot for that. What about others? 54 out of 54, I think 2 or 3 are our faculties only. But what about the remaining 48 people? Not enjoyed, not enjoyed. What exactly your feedback? If you have any feedback, of course you can give it to me. I'm eager to learn and improve myself if it is required. That's what I said. I'm a student all the time. That's a great, Sushmita. You said enjoyed a lot for that. That's a great thing. All right. So I am done with my part of the story here. Now I will hand over session to Ravi Kumar sir or maybe Anusha madam to take it forward. If anything formality to be done, please complete it and we'll close the session. Thank you.
Yeah, sure, sir.
Yes.
Anusha madam, are you ready?
Yes, sir. Ready.
Okay.
Let's start the validity function. Yes. Now we are at the end of our today's workshop on PCB design, organized by Jain Institute of Technology in association with ERK Innovation Private Limited, Hubli. Now I'd like to welcome Dr. Santosh Sherur sir, HOD, Department of EC and IQAC Director, JIT Davangere, to this validatory function. Welcome you, sir.
Hello, sir.
Yeah, am I
Yes,
audible?
sir. Yes,
Yes,
sir.
sir. You are audible.
Yes,
Yeah.
go ahead,
Thank you.
sir.
Thank
Yes. Welcome you, sir. Firstly, on behalf of Department of EC, JIT Davangere, I like to thank our resource person, Mr. Vaibhav Sugandhi sir, for sharing such a great information regarding the basic schematic and also layout design of the PCB. Thank you, sir. During this short duration, you have rendered a great information. Thank you, sir.
Welcome, welcome. My pleasure.
Now I request Dr. Santosh Sherur sir, HOD, Department of EC, to share his thoughts and wish all our participants. Over to you, sir.
Yeah, good noon to all. Am I audible? Let
Yes,
me
sir.
ensure.
Yes, sir.
Yeah.
Yes, sir.
First of all, I would like to wish a good noon to all present here through online. So almost we are at the end of workshop. We call it as a valedictory. But let's not leave this kind of skill called as PCB designing or as such here itself. Let us also render it in to our practice. So we started this workshop yesterday morning with the objective of helping students, participants to understand the industrial PCB designing skills as per the industrial protocols. Okay. So at least the participants will be able to design simple schematics and PCB live in the workshop. So this was our as well as resource person's motto or objective. The outcome is that the participants is now able to design a single layer, single sided and industrial. Son Mr. Vaibhav Sugandhi, CEO of eArt Key Innovations Private Limited, have kick-started you all by imbibing all his PCB designing knowledge or skills into your minds. Now that it's up to you whether you would like to carry out and implement these skills in your hobby projects, mini projects, final year projects, etc. I appeal to all present, all participants. Okay, I'd like to appeal here to kindly bring your skills into practice. Unless and until you practice, whatever you have learned will go wasted, and after a couple of months without practice, you'll forget much of the things. Okay, so just bring it into your practice. If you practice, then only this workshop will be kept live for as long as you keep practicing. My best wishes to you all participants for your future endeavors. My heartfelt thanks to Honorable Resource Person Mr. Vaibhav Sugandhi for lots of such interesting sessions through it. It is online. Okay, though it is online, you kept all sessions very lively and very interesting. Congratulations to Anusha Madam, Ravi Kumar sir, and Shrikant sir for having coordinated this workshop, for all your efforts in making this workshop of 2 days, that too through online, a successful one. I also thank Principal Sir Dr. Ganesh DB for encouraging such workshops in our college premises, though it is online. Okay, so thank you all once again. So as I said, just convert your skills into the practice. Okay, that conversion ratio should be of high. So thank you all once again.
Thank you, Santosh sir, for your constant support
Thank you,
and
sir.
also
Thank you very much.
thank you, sir.
Yeah, welcome.
And I take this moment to thank our co-organizers, Professor Ravikumar Kyai and Professor Shrikant Devi sir, for their support in the successful conduction of this 2 days workshop. Thank you, sir. And I like to thank all the participants from BIT, GMIT, Jain Polytechnic, and also JIT for attending this 2 days workshop with a lot of patience, interest, and also making this event a successful. As this PCB designing and its learning is a never-ending yet, but it's an interesting process too. Hope all our students now got the basic idea about this PCB and its designing process. Now I request our participants to share their opinion regarding this 2 days workshop. Any of the participants like to share your views can go through.
Can I add something, Anushka madam? I
Yes,
just
sir.
wanted to have something.
Yes, sir, please.
Yes, sir.
Okay, thank you. Uh, See, guys, it was a wonderful time. I have literally enjoyed the process of sharing my knowledge with you guys. Personally, I enjoyed for whatever I have delivered to you right now. There is one important matter that you have to remember. In fact, this is a Sanskrit shloka which my teacher, who is a godfather in my diploma, shared with me. And it kept kept motivating me to go in the field of PCB designing, or maybe in the field of entire journey of life, I could say. Okay, and this shloka is something which is very essential for every student to understand. When we have 100% learning, say for example I have a knowledge to be learned in 100%, how you can learn it. So my teacher said me in wonderful shloka. I try to repeat it. I'm not good in Sanskrit. If I'm mispronouncing anything, please sorry for that, but still I can tell you something. Padam acharyamaditya, padam sajjana sangastya, पादम स्व अर्जित, पादम कालक्रमेण. अर्थात padam in the sense 25%. So 25% of your knowledge is trained by any kind of a teacher, no matter who that teacher is. It may be a world's best teacher, or maybe a simple teacher in your locality. Doesn't matter. Any teacher can teach you any knowledge regarding anything in the life, only about 25%. That is the top notch possibility from the teacher. And the padam, which is a 25% with a sajjana sangastya. What means the kind of people you live with. If you live with PCB designers for the next 1 year, you are going to be the one. If you live with programming students or programming friends for the next 1 year, you are going to be the one. If you live with some people who do not have any motto about the life, and just to mess up with the parents money, and just to go out of the college, something like that, then you will be the one. So make sure that you have 25% conversation, or maybe 25% learning from the people you belongs to, or people, the community you belongs to, the group circle you belongs to. And the remaining 25% is all about swa arjitha. Swa arjitha in the sense self learning. No matter which university you are studying, no matter which country you are studying, no matter what kind of a lecture you have, it's always your responsibility to take care of the 25% of your learning, which is padam swa arjitha. And the last but not the least, padam kalakramena. What means as time goes, you start learning the things. As I already said, you are doing the PCB designing for the first time, so I don't expect you to create a professional PCB like I have done in the screen, but at least keep trying, keep trying, keep trying. By the time you become 1 year old in the PCB industry, you could do even more better than what I'm doing today. Possible, because it is all about your effort and your individuality. So do remember these 4 sections of learning square, where we have 25% from the teacher, 25% from the friend circle, and 25% from the way in which you are learning, which is all about self-learning, and 25% as time goes. Having said that, thank you. Do remember this one. That's what Herure sir is also able to wanted to say it to you. Keep in practice. That's all.
Exactly same thought.
Thank you, sir.
Yes,
Such a great word. Thank you.
no problem.
Any of the participants like to share your opinion regarding the today's workshop can share. Please unmute and speak out your words.
I hope I'm audible.
Yes, you are.
First of all, I'd like to thank the Institute and Vaibhav sir for giving us so much of information. It was very useful. Thank you very much.
Welcome. Welcome.
Sir, even in the future, if we have any kind of doubts, we would like to ask you and for your advice as well. So please do guide us in the future as well.
Of
Thank you,
course,
sir.
always welcome. Always welcome.
Thank you.
Welcome.
Thank you, Meryl. Now, I would like to request our resource person, Mr. Vaibhav sir, to share your experience and share your thoughts. Thank you.
All right, Anusha. Already I said about that. So I literally enjoyed the process here. Only thing is, I'm expecting some of your college students, or maybe some of all these students. I think more than 150 students attended this particular session in YouTube streaming as well as in our Google Meet. I expect at least 10% of the people are inclined toward hardware design engineering. Because what happening everywhere, software is booming. People think that software is only the way they can grow in their career, which they literally misunderstood. Because if you develop a software, if there is no hardware to deploy that software, how do you develop it and how do you deploy it? So that's why there should be some people who are responsible for developing a hardware, and hardware development is nothing but PCB designing at the core level. Okay, so keeping that in mind, I request every one of you, please take it serious. If you're really interested, we have warm welcome to you for further assistance and any kind of guidance as much as possible. If you are sending me any questions in the WhatsApp tonight, if I'm not responding within 5 minutes, don't blame me. I'll be having some other work to be done, but I'm very sure by tomorrow morning I'll be checking with your messages and I'm going to reply back to you. There is no such message in my WhatsApp that I have not replied from the long time. Not at all, not more than one day. So I will give my commitment and I will give my all the effort to help you to become a PCB designer, but it takes you to choose for that. Having said that, I enjoyed the entire process. I love the way I shared my knowledge with you guys, and I could also see some of you students are very interested, like hooray hooray saying on the chat window. Keep that motivation, keep that child within you, and continue learning PCB designing. Thank you.
Thank you, sir. Thank you for making the 2 day session more interactive and also more joyful. And also thank you for your support in the successful conduction of this workshop. Thank you, sir.
Welcome. See you guys. Bye bye.
Yes, thank you.
Madam, any announcement regarding feedback? You can feedback link and all.
Sir, feedback link is shared, sir. The students will get the certificate through the registered mail ID after filling the feedback links.
Yeah, fine.
Thank you, sir.
All of you fill up the feedback link here. From that, we can get the e-certificate to your register email ID. Okay, so don't miss that one. Okay, thank you all.